Hi everyone, welcome to the 40 Bombala YouTube channel. I'm Ravindu and today we will be talking about implementing GPT agents with the OpenAI API. This is our first video, so please excuse any quirks and technical difficulties I might run into. A little bit about me, I'm currently working as a .NET developer, and as such I decided to show the examples that I have implemented in .NET. But before we jump into coding, I want to have a quick intro to what we will be discussing today. So coming into 2023, you can see how OpenAI is building up on the momentum they had from last year. We got to see the release of the GPT plugin support and the OpenAI API suite, which I will be using in this video. But with all these features that has been released, I still feel like most of the general public that uses ChatGPT on a daily basis, or even some of the developers, don't really understand the full capabilities of these extremely powerful services. Before we continue any further, I want you guys to know that the patterns and the code examples used in this video is highly experimental. By no means should you be using these in a production scenario without any validation. So take this video and the contents of it as a learning opportunity and improve your imagination on how you can use the GPT APIs offered by OpenAI in a different context rather than just using them for Q&A purposes. So this video is going to be about building agents with GPT APIs. This is not a new concept. I am not inventing this for the first time. These are things that have been discussed in the data science community for a very long time. But I wanted to make this video targeted towards web or software developers who may have not seen much use cases of GPT models apart from ChatGPT or Copilot. I wanted to show them there are other ways of using the GPT models to your advantage. So GPT models can be given an initial context before a conversation starts. This context can then set a role for the assistant to play in a particular scenario, and you can even define boundaries. So this whole process effectively turns the model into an agent that caters a particular use case. Now, you can tell an agent to bark like a dog, or an agent can pretend to be a Linux terminal. So the possibilities are quite endless. You can kind of consider this process as agent priming, where you prime a particular GPT or another large language model with a context in order to get it to play a role of an agent. Now, this becomes really powerful with the OpenAI API because you can automate this whole process and scale it to the next level. And today I will be showcasing some agents that I have written in .NET. Big shout out to the Bitalgo team for writing a really nice wrapper around the OpenAI API. So without further ado, let's jump into the code. I will include a link in the description for you guys to follow to create an OpenAI API key, but let's focus on the project for now. As you can see, it's a solution that has 3 C# projects underneath. Let's ignore the console project for now because this was done primarily for testing and validation of the core code, but let's focus on the core and the web projects. So core is essentially a class library. Before I jump into the agents folder, I'll show the dependency injection layer. So as you can see, we are using the package that I mentioned before, and anyone who wants to consume this core library can use these extension methods to register the agents that I have defined. Now let's look at how the agents are present. So I have written a few different agents for the sake of this demo. I'm not using all of it in the web project, but I will go through each to showcase how they differ. As you can see, there's a intent classifier agent, a knowledge oracle agent, a sentiment analyzer agent, a support agent, and finally a text extractor agent. So let's take a look at the sentiment analyzer agent. So the sentiment analyzer agents is simply a class that extends a particular base class and implements an interface, both of which I will cover in a little bit. But I want you guys to focus on this context and see what the hell is going on here. So this is where I instruct this particular agent to pretend to be something else. In this case, I'm asking it to pretend to be a sentiment analyzer instead of the standard GPT chatbot. So I am simply instructing it in natural language to analyze any messages that it gets and grade them from a value range ranging from -1 to +1, where -1 is extreme negative sentiment, 0 where is the neutral middle, and 1 is positive sentiment. And that is all this agent will do, thanks to that boundary that we set via this context message. The constructor is quite simple. I'm simply getting the OpenAI service injected and passing it back to the base class along with the context that I defined here. And I'm setting the model used by this agent. It needs to be GPT-4. The ask method is where the actual question is going to be asked from the model, and this will be passed as a parameter from the web project. And I want you guys to see what's happening here. I'm actually confident enough that this model will always return the output in the form of a float rather than it's going to answer a particular question. So I'm going to convert that response back into a float. Now, in the real world, obviously you will need to put some safeguards in here, but let's talk about that later in the limitations section. Let's take a quick look at how the base class works. So the agent base is simply an abstract class that holds the variables that the child agents will pass into it. And also it offers a few methods to configure and tweak the model a little bit, namely temperature and the model type itself. So you saw in the sentiment analyzer agent how the default 3.5 turbo model was overridden by ChatGPT-4. The temperature I'll talk about in a little bit. The getResponse method is where I use the chat completion's createCompletion API to actually generate a response upon a question that is given. The fromSystem method is used to define the context that was defined in the child agent classes, and the fromUser message is where the actual questions that gets asked inside the website gets passed into. I also set the model and temperature based on how it was tweaked, and once the result is out, what I will be doing is checking whether it's valid. If it is invalid, I will throw an error. If it is valid, I will choose the first answer and return it back. Now, obviously, this can be improved. There might be multiple choices here. You might be wondering why there is a second getResponse method. The only difference between this and the previous is that this takes a list of messages. This is because some of the agents have a state compared to the stateless agents. The conversational agents tend to have a conversation history preserved for better responses coming from GPT. So for those agents, they will be using this overload where a list of messages can be processed at once. Now, let's take a look at the interfaces that are used for dependency injection and also for defining the contract that the web layer interacts with. So each of these agents has an ask method that has a generic type parameter. So the generic type parameter is there because you want to define the agents that might not return just string as their output. As you saw in the sentiment analyzer, it used a custom float type, but the other agents mostly use the string return type. Let's take a look at the sentiment analyzer agent again, and you can see the float conversion that is like happening here. And in the interface for the sentiment analyzer, I define the type while implementing the interface. Okay, enough talk about double OP stuff. Let's actually get down and dirty with the demo itself by kicking the web project off. So I didn't go deeper into the code of the web project, but simply it's created using the Blazor server's default template. I have removed some of the default example pages here and replaced it with 3 different pages that showcase 3 different agents. Let's start with the first one. So the text scraper agent, actually the text extractor agent in the code, is an agent that simply takes in an HTML string and tries to return the raw text output, raw text inside that HTML string. So let's see. I have a sample HTML payload in here. Taking a quick glance at it, you can see the raw text that's inside this is the welcome to the text extractor test, and this paragraph tag, and that's it. Actually, even I got confused for a second there. We do not want this link information in there. We just need remember to visit our website for more information. There's also a console log here. I have added a test message here that says this shouldn't be extracted by the text extractor model. Let's see what happens when we paste this in. Oh, it did exactly what I expected it to do. It was intelligent enough to not extract the JavaScript code or the A tag. And also it completely ignored the style tags and the other unnecessary tags for this operation. Now let's take a look at like how this happened in code. Let's go to the text extract agent. There it is. You can see this has a shorter context compared to the previous one I showed, but it's fairly simple. When you receive a valid HTML payload, carefully process it to extract the textual content within. Ensure that you remove all HTML tags, scripts, and other non-textual elements while preserving the readability and the structure of the text. Straightforward. But you might notice like why I added this temperature here. To do that, let's talk about theory a little bit. Ta-da! We are back to the theory page. Now, from what you guys have seen so far, you might be feeling a little bit like weird. I know the first time I did it, I felt a little bit weird as well. I think the reason for it is, as developers, we are so used to writing deterministic code. Meaning, when we are interacting with an API or a library or a service, we know that there's a definite standard, a query or a command that we are issuing to that service should be written, and we know that the response that will come from that service will always follow what you gave into it. If you follow the standard, it'll return the output correctly as well. But GPT is a natural language model. Natural language is a very random thing. It's not deterministic. Some people might not get sarcasm. Some people might not get a hidden joke. So now we are issuing these commands and queries in natural language, in a context that is defined in natural language, where there is so much room for things to go wrong. That is precisely why you need to ensure a few key things before you implement a pattern like this. The first is you need to keep the context of your agents as concise as possible. You need to go back to your software engineering theory and think of the single responsibility principle. Rather than getting an agent to do many different things, the agent will try to perform as deterministically as possible when you give it a scoped set of responsibilities or just one responsibility. At least that's what I have found in practice. Maybe down the line, as GPT gets more and more stronger, you don't have to worry about it. It'll be intelligent enough to extract all the necessary responsibilities. But from my experience, it's very powerful when you scope it. The second thing that you need to understand is that OpenAI allows you to enforce deterministic nature via the configuration, and that is what you saw in the temperature parameter. So when this temperature parameter is set to 0, whatever that goes in, there will always be a deterministic output by the model. Now there's a bit of a drawback for this. Doing so will eliminate the stochastic random nature of the model and make it a little bit like less creative. You can think of it as like you're kind of lobotomizing the model a little bit. You might be thinking, what exactly is the benefit of this pattern? Like, why don't you use a library to achieve this? And that is exactly my point. You didn't have to use a library. You used ChatGPT instead. GPT is what acted as your library, and you interacted with it using natural language. And we basically eliminated the need to learn the library and learning to deal with like edge cases. Now, obviously, there are drawbacks. First, you have the cost. OpenAI will charge you per each request, following the token metric that they have. The higher the number of tokens, the higher the cost. And GPT-4 is way more expensive than GPT 3.5. This can balloon up like real fast. The second is the previous thing that we discussed. The output is not 100% deterministic. As OpenAI further improves these models, most of these issues will be eventually tackled. Now let's get back to the demo. I'm going to show you how the chat functionality works now. So for this, I used a existing Signal chat room template and tweaked it a little bit so that there's no socket connections. It's just you enter messages and ChatGPT responds back to you. Let's enter the chat room. And boom, you have the Knowledge Oracle agent replying to you saying, "Hello Rav, welcome to 40 Bank's chat support." Let's see how this exactly happens inside. So out of all the agents that I've built for this demo, I would say 40 Bank is the fakest. So let's go to the source code of the Knowledge Oracle agent. And as you can see, all I've done is instructed it to pretend to be a chatbot from the 40 Bank. And based on the questions, the common questions that you might get about loans, credit cards, online banking, just give a relevant response. The difference from the previous agents that I showed to you earlier is that it persists the chat messages array here, list to be precise, and it maintains a conversational history prior to returning the responses back to the UI. Now, obviously, this conversational history is not getting stored in a database or somewhere. This is purely running in memory, but for the sake of the demo, it works. And having a conversational history improves the intelligence and the quality of the responses that you get out from the chatbot. Let's ask it a legit question. How do I apply for a home loan? And let's send this. Boom, you got the answer. This is, again, not real. It was completely hallucinated by the Knowledge Oracle. But for the sake of the demo, it works perfectly fine. And now I'm going to show you another agent in action in here. So I'm just going to say, this is useless. Don't be mean to chatbots, folks. I'm saying that so that our robot overlords in the future will see this message and know that I supported you guys. And boom, you got a, "I'm sorry that you're frustrated with me. I'm still learning." Okay, now I'm going to demonstrate the final agent, the support agent. What this will sort of demonstrate is agent-to-agent communication. So the support agent is someone who takes the role of replying to customer emails. But the support agent alone cannot handle all the questions that a customer might have. So instead, what it does is it goes to the Knowledge Oracle. And the Knowledge Oracle processes all the questions one by one, and once the support agent has enough information coming from the Oracle, they compile the final email and then it goes back to the user. Let's see how this happens in code. Alright, now we are in the support agent class. As you can see, this is probably the longest context prompt I have written, so I'm not going to go through all of it, but it's fairly describing what I explained earlier. One thing you guys need to pay attention to is, look at this finalize tag here. So when the support agent has all the required information from the Knowledge Oracle and it is ready to print the final email, it's going to tag that email message, that message containing the email with this finalize tag. This will indicate the program which is orchestrating this interaction between the two agents to terminate. The main differences between this agent and the other classes is that it has an association relationship with another agent, in this case the Knowledge Oracle. And In the ask method, you can see, similar to the knowledge oracle, it is persisting its own conversation history. And once the initial message is received from the agent, it's going to enter a while loop with a continued conversation between the two agents. And this conversation will only finish until our support agent responds with a final email with that finalized tag. And the moment that happens, it gets returned back to the user. I'm going to replace that finalized tag for readability. I also added a custom method to write this entire conversation between the two artificial intelligences so that we can impress ourselves in a little bit. I'm going to navigate to the support section and I'm going to copy the email and paste it here. Be ready, this is going to take some time. I finally got it. That took a while. Now let's see what exactly happened behind the scenes. Right, we have the file here. I'm going to zoom this and then let's go through this section by section. The first one that went into the agent is the initial prompt, which is the email itself. So once the email was received, since the assistant was primed with that initial context, what did it do? It first extracted the question that it needs to ask from the knowledge oracle. It says, knowledge agent, what are the requirements for opening a new savings account with Fortibank? Can customers complete the process online or do they need to visit the branch? And the knowledge agent replies, to open a new savings account with Fortibank, and gives all the required information. And when that information is passed into the assistant, into the support agent, it asks again, knowledge agent, what are the current interest rates on Fortibank's savings accounts, particularly those with high interest rates? And it goes back to the knowledge agent, and the knowledge agent answers with the appropriate information it needs. And finally, it's going to print out the final email that it constructed. What a good support agent. All right, since we have gone through the code and looked at all the demos of the agents, I think it's time we talk a little bit about how we can improve these existing agents. One way to tackle this is having a prompt validator agent that verifies all the queries and commands that goes into different agents. This validator can check for anything unrelated or malicious. Secondly, the same pattern can be applied for responses coming out of agents as well, because most of the time these responses are in natural language and it is very hard for us to validate whether an agent was able to successfully answer a question or not. In those scenarios, we could have a response validator agent which checks the message that was sent by the user and the response a particular agent gave, and if it decides that the agent answered the question successfully, what it'll do is it'll enrich the response with a further verification saying that this message was answered, this query was answered. You could think of it as adding HTTP status code 200 OK to a response that is coming from a particular agent. All right, with that being said, I think it is time to close this video. So if you made it to this point, I hope you learned something new, and I hope you guys will check out the OpenAI APIs. As you can see, they are very powerful and you will definitely see more and more companies building new products utilizing them. I hope you guys enjoyed the video. If you did, don't forget to like and subscribe. I don't know when our next video will be, but I hope to get one out pretty soon. Thanks for watching.